Hey guys, so as discussed, today I'm going to take you through the process injection method and specifically the DLL injection technique, which is a very common one. So let's start from taking a look at the MITRE framework. We can see different tactics along with optional techniques that attackers are using. One of the common techniques is called process injection. In this technique, the attacker goal is to inject malicious code by allocating and inserting the code into the memory space of a legitimate remote process, and then the process will execute the malicious code. So we can find this technique in the following two tactics. The first one is the defense evasion, which referring to the method that malware is trying to avoid detection, and in the privilege escalation tactic, which referring to gain higher level of permission on a system or network. Process injection can be performed in many ways, as there are multiple approaches to inject code into a live process. You may take a look in the MITRE page of process injection. I will attach a link below, and you can go through the different techniques except of DLL injection and read about them. So let's see the general approach of the process injection. First of all, we have a malware process, let's call it a launcher or loader, that injects malicious code. The malicious code can be either DLL, executable, or shellcode. And we have a legitimate process, such as Firefox, Explorer, Chrome, which the code will be injected to him and run. The launcher needs to first identify the process to inject the code. This is done by enumerating the processes running on the system. By the way, keep in mind, sometimes instead of injecting code into an already running process, malicious program launch a new process and then inject code into it. So in this high-level diagram, you can see the malicious process, which this strange error I will talk about it in details in the steps of the attack, which inject his malicious code within a targeted process. So this is the general approach. Now when we are talking about DLL injection particularly, so the DLL, Dynamic Link Library injection technique, or remote DLL injection, is an injection technique that loads a malicious DLL inside the context of a legitimate running process. Again, the target. So as we said, the difference between the general approach is that in the DLL injection, specifically we're talking about injecting a DLL, the path of it or the content of it. So before again we dive into the steps and I will show you how exactly you perform this attack, I want to be sure that you are familiar with the virtual memory concept. So what do I mean in the virtual memory? When you double click on a program containing a sequence of instructions, a process is created, right? Let's call it process A. The Windows operation system provides each new process created with its own private memory address space. We call it the process memory. The process memory is part of the virtual memory, not a real memory, but an illusion created by the operation system memory manager. This way, each process thinks that it has its own private memory space. Then, during runtime, the Windows Memory Manager, with the help of hardware, translates the virtual addresses into the physical addresses in the RAM where the actual data located. So this is the important thing. It means that the Windows Memory Manager translates the virtual addresses that we have into the physical address, the actual RAM. Same thing for additional processes. So we have in parallel multiple processes that are running, thinking that they have their own private memory space, the whole RAM, but actually it's not like that. There is the Windows Memory Manager, with the help of the hardware, translate these virtual addresses into the RAM. We normally deal with virtual addresses, let's say the ones that you see in your debugger. So we will see and talk about the virtual addresses and not the physical addresses themselves. Now, put in mind, the virtual memory is separated into process memory, which related to process space or user space, and the kernel memory, which related to kernel space or system space. So we have two parts within the virtual memory. We want to concentrate and be focused on the process memory. This is what's relevant for us while talking about injection techniques. Okay, so let's deep down a little bit more on the process memory itself. We understood that we have the process memory within the virtual memory, and now let's see what the process memory is. So the components which the process memory has, first one is the DLL, the dynamic link libraries. This region represents all DLL associated with a process which get loaded into the process memory when the process is created. PEB, which means process environment block. The PEB contains information about the executable itself, where is loaded, its full path on the disk, and where to find the DLLs in memory. The process heap. Each process has a single heap and can create additional ones if needed. The region specifies the dynamic input that the process receives. Thread stack. This region represents the dedicated range of process memory allocated to each thread. Each thread gets its own stack. Lastly, the process executable. This region contains the executable associated with the application. When a program runs, a process is created, and the executable associated with the program is loaded into the process memory. Okay, so as we said, the virtual memory also contains the kernel memory part, separated from the process memory, but contains different components. Now that we are familiar with the general approach of process injection, and we know what is virtual memory and process memory, let's talk about the DLL injection technique itself. In this technique, the target, the remote process, is forced to load the malicious DLL into its process memory space. So again, the remote process, the target process, is forced by the malicious process, so it's forced to load the malicious DLL into its process memory space. So first of all, a malicious DLL drop onto the disk. It means that on the system there is an already existing DLL. Any kind of initial access technique can be done here. So you can find the initial access techniques in the Mitre framework, but it's not relevant for us. So now we can continue the technique itself. The malware process, let's call it launcher exe, identifies the target process. Let's call it target.exe, which is a legitimate running process, and then get his process ID. Okay, so launcher exe wants to get the process ID of target exe. Okay, so the goal in this step is to open a handle to the target process so our launcher can interact with target.exe. And for this we have APIs, specific APIs that I will show you how we are monitoring in order to detect this kind of activity. Okay, so in each step I will mention the related API to this step. Now we need a place to inject the malicious code. in our case, a malicious DLL. The launcher.exe allocates memory within target exe, the legitimate running process. 4. We are allocating memory in order to copy the full path of our DLL to the target process. We will use here the address of the allocated memory. Now, just before the launcher exe creates the remote thread in order to make target exe to execute out malicious DLL, we need to determine the address of which the remote thread will start to execute. And this address is the address of load library function. This is important point. So we need to get the load library address, and we are doing it by the next step. Okay, so at this point things start to get along as we are very near to successfully executing our malicious DLL on behalf of another process. We have our full path of DLL in memory, and we know the memory address we would like to start to execute. So launcher.exe creates a thread in the target process which will start executing at the address of load library. The load library, in his turn, will use the address in the target process memory, which contains the full path to our malicious DLL. That way, the thread created in the target process invokes load library, which will load the DLL itself into the process memory. Eventually, once the injection is completed, the launcher exe closes the handle to the target process, and we can say that we eventually close the handles and finish the injection. Okay, so now we can move on to see in our own eyes a process injection in live. So I have here a malware and a sample which I downloaded, which one of my sandboxes. This one will inject to explorer.exe if I'm not getting wrong, if I remember. Let's see. So we will use two tools. API monitor, which I will add the link below if you would like to download it. So this is the API monitor 32-bit, because I'm working with a 32-bit structure file. Of course it has the 64-bit structure as well. And I will launch the Process Explorer, the magnificent and wonderful tool of Sys internal suite. We will take a look while the malware is running. Okay, cool. So before that, let's open the presentation, of course, and here we will take from here the specific APIs, and we will find them here in order to monitor them while the process is running. Okay, so this will be the points we will want to see if the malicious program is doing. So the first one, let's open process. So we can, it's not this one. Okay, so we have anti-open process under the anti-DLL. Anti is another version. We basically will pick also the anti one. Let's take also the virtual alloc. Each one is relevant to another step, as we discussed in the last slide. Okay, virtual alloc exe and virtual alloc and virtual alloc extension. Great. Write process memory, very, very important. It's in the step 3 when we copying the full path of the DLL to the target process. This is what actually does it. And another version of write process memory, it's also the anti-write virtual memory. Let's monitor it as well. Anti-write virtual memory. Also, we will pick the anti-allocate virtual memory. And okay, load library, of course, on this one, down. Okay, so load library under the kernel 32 DLL, load library A, and load library extension A. Perfect. Okay, let's also put create process. Okay, it should be up in the hierarchy. Anti-create process. Okay, I already have it, and any create process. And I think it's in order to get the process ID. You remember in the first step. Let's look also for find window or get window thread process ID. Get window thread process ID. Perfect. So okay, so now that we know what we want to see in the list of the APIs, I'm going to put it aside, and let's take a look also in the same time at the process explorer. I will execute it, the malware, by myself from here. Okay, so this is an executable. Open and run. We can see it here, malware exe, which the parent process is the API monitor, of course. We can see a child process of CMD. Suddenly the malware exe deleted, and we have another multiple child processes with the same name, system info. The CMD just deleted the malicious process, and actually deleted himself eventually. So this was a very fast demonstration. Let's see what happens here in the API monitor. So we have the allocate virtual memory, right? So if we will take a look at our list of okay, so if we will take a look at our list of the APIs that I put in the DLL injection steps, we can see that the anti-allocate virtual memory is here. Okay, it's actually in the notes, but you will see it as well. The write virtual memory and the resume thread, okay, which means that we know that the injection itself is over when we see the resume thread. Let's take a look at them, and we can actually see that there is in the write virtual memory, okay, which again is the we know that it's write, okay, it's trying to write in this step, it's write the content of the buffer to the virtual memory portion. So it's this one, and we can see it in exa. And by looking at these steps, we can be almost sure that we are looking at a process injection program because of those strange APIs, not strange but suspicious in terms of the sequence of events. So guys, I think we will continue in another session. I will find a much better malicious program which performing in DLL injection, and then our mission will be to actually find the content of the DLL within the target process, and then we will try to deobfuscate it together. So here in this video I mainly want to show you the how DLL injection works, okay, going through the steps. If something is not right and still not clear, you can text me, it's okay. And see you in the next section, I think. Thank you very much.